Hey students, how's it going? We're going to do the 10-3 notes here really fast. These are really easy. This is just an extension of the 10-2 ideas. So radicals, combining like radicals. So you can combine them just like anything else. If you had 6 things plus 9 things, you would have 15 things, okay? So just like variables, just like things you can count, radicals can be added and subtracted just like that. That's it. So if you want to take this time to put that into a calculator, I guarantee you're going to get the same decimal estimations for both, all right? So here we go. Now the only trick is what happens when it's a lone square root. Well, here I have the square root of 3 minus 5 square root of 3. How many is this? This is 1, okay? So anytime you have a lone square root, just like a lone variable, remember if you had an x, technically that's 1x, okay? You have a lone radical, that's one of them. So one thing minus 5 things would be negative 4 of them, okay? So that's really simple, all right? Combining radicals is just like combining anything else. You just count how many you have and then do the math. I'm going to go right into the next piece. So what happens, oh, by the way, this is linked to EE.5 IXL. So an extension of that is what happens when you have to simplify before you combine. Sorry, this is the square root of 12. I apologize for that. So what happens when you need to simplify before you can combine? Well, right here, I can't do anything. So up here I was lucky and I had the same radicals, 11, 11, 3, and 3. If they're different radicals, you have to see if you can rewrite one of them before you can simplify. Okay, so right now I've got 5 square roots of 3 minus the square root of 12. There's nothing I can do unless I rewrite the square root of 12. Well, the square root of 12 is 4 times 3 the last time I checked. Square root of 4, that's a 2, and then 3 stays a 3. So this is actually 2 square roots of 3. I carry the operation along for the right here. So I have 5 square roots of 3 minus 2 square roots of 3, okay? Because the square root of 12 can be rewritten as this. Again, if you have that chart completed, you can see that as well. Okay, so the chart that I emailed you all, right here, double check, square root of 12. Yep, there it is, all right? So 5 things minus 2 things is going to be 3 things. So 3 square roots of 3, okay? Right there, all right? So let's take a look at this one. What happens if one of your radicals already has stuff on the outside? Well, no big deal. Let's see if we can rewrite the square root of 28 as something to a square root of 7. I think I can. Let's check the chart here really quick. Square root of 28, 2 square roots of 7. Okay. So this by itself is going to be 2 square roots of 7. Okay. But then I had 2 of them already. So 2 times 2 would be 4. So I've got 4 square roots of 7. Plus 4 more square roots of 7. So that's just going to be 8 square roots of 7. Notice when I do addition, I don't make a brand new radical. I keep it the same. It's just like adding and subtracting things, okay? If I had 4 things plus 4 things, I have 8 things. I don't change what I added together. It's still the square root of 7. Okay, so again, if you have a number already on the outside, keep it on the outside. Rewrite the radical as best you can. Again, use the chart. Okay, if I didn't have the chart, what would I do? Well, square root of 28, I could rewrite that as 4 times 7. Square root of 4 is 2. 7 has to stay since it's not perfect. I had 2 of them, and I've got 2 more, so 2 times 2 is 4. 4 plus 4 is 8. All right, that's it. So that is combining like terms and sometimes having to simplify before you can combine like terms. All right, that's it. Moving on to the next example here in a second.